now we are going to study with the rules that has to be followed while filling the orbitals, because now we have reached to a level, like we have already done the concepts and all. Now we have reached up to the level where we are going to fill the orbitals. That means we are going to write the electronic configuration. So when we are going to write the electronic configuration, that how the electrons are arranged in the orbits or the subshells on the orbitals, we need to know certain rules. So my first rule is of Bohr principle, right? So what does it states? It states that when we will fill the orbitals, like when we start filling the orbitals, we have to fill the orbital with the lower energy first, and then the orbital with the higher energy is filled. So this is what I wrote here, that electron enters the orbital with the lower energy first. That means when we will just fill the orbitals, we need to enter, like the electron will enter to the lower orbital with the lower energy, and after that we will fill the orbital with the high energy. Means then according to their subsequent energies, we will be filling the electrons in the orbitals. Now the question is that how will you come to know that this orbital is going to possess less energy or this orbital is going to possess more energy? So there we have a rule, that is Bohr rule, and what is that? That is N plus L. It is N plus L. What is it? Like suppose I give you two orbitals, like I say that, like if we talk about subshell first, if I say that it is 2s and it is 2p. Compare their energies. So what you are going to do? You are going to do N plus L. So in this, what is N? Obviously it is 2, because we know that second orbit means the N is 2. And what is L? For S, L is 1. So it comes out to be 3. And for 2p, again N is 2, and for P, sorry, again I'll just write again. See, 2 is our N, S is 0, L is 0 for S. So it comes out to be 2. And when we talk about 2p, N is 2, and for P what do we have? We have L is equal to 1. So energy is 3. So if we compare their energy, so which is going to possess less energy? 2s. And which is going to possess more energy? That is our 2p. So that means when we will fill the orbitals, then what we are going to do, we are going to use the procedure in which the electron will enter into the orbital with the lower energy first. That means when we will fill the orbitals, the electron will enter the 2s first, and after filling the 2s, it will enter the 2p, because 2p possess higher energy. So this is how you compare. But sometimes you will encounter a situation in which, like for example, I tell you to calculate the energy for say 3s and 2p, right? So what is the energy for 3s? Obviously it is 3 plus 0, N plus L, comes out to be 3, and for 2p it is 2 plus 1, comes out to be 3 again. So in this situation, what will you do? Like if the energies are same for both the cases, so if N plus L result is same for two subshells, then you are going to fill the orbital or a subshell which has the lower value of N. So in this case, which has the lower value of N? Obviously 2p. So that means it will possess less energy, and we will be filling 2p first, and after that 3s. So likewise, because we have so many subshells to be filled, so what do we do? Actually, when we just fill them, so like when we fill them, we use a certain order, and I'm just telling you that how you can know that order. So it is 1s, 2s, 2p, you need to write that. See, it is 1s because the possibility of one orbit to have a subshell is only 1s, and likewise we have 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, and likewise I have wrote till 7p. Now the orbital with lower energy is first subshell with lower energy is S. So we'll write the order. I'll write the order here. It comes out to be 1s. Then it is 2s, right? Then 2p and 3s. Then 3p and 4s. Then 3d, 4p and 5s. I think you got it. You need to write the subshell from this side to that side. Then again we have 4d, 5p and our 6s. Then we have 4f, 5d, 4f, 5d, 6p, 7s. So and then 5f, 6d and 7p. So likewise you will be writing the subshell. No need to cram it, just make the chart like this, and just like I put the arrows, you also put in the similar way, and you will get the result. right. So this is what like we'll be using the Bohr principle, and what is that? That when you are filling the subshell, then the electron will enter into the orbital, or it means the orbital which is possessed in a subshell, that which has the lower energy, and likewise you will fill the higher energy, and then more energy goes on increasing. So likewise the electron keep on entering the you can say orbital of the subshell with the lower energy first, and then the higher, then the higher, then the higher, and likewise we will be filling them. So this is the first rule you need to follow, right. So what does Bohr principle? The first rule which has to be followed, that when you are filling the electrons, so electrons enter into the orbital of a subshell. I'll write here orbital of a subshell, obviously because we will be comparing energy of the subshell with lower energy first, and then the subshells, the orbitals of the subshells of the high energy gets filled, right. So this is what, and how you come to know about the energies? Obviously by adding n plus L, or by getting the result of n plus L. And if the n plus L result comes out to be same, I told you, then you will be taking into the consideration that the subshell which has the lower value for n is going to be filled first, as I took an example of 3s and 2p, right. Now we have done with the first rule. Now the second rule is Pauli's exclusive principle. Second rule is Pauli's exclusive principle. We did when we did quantum numbers, I told you there also that as we saw that there are a set of 4 quantum numbers, and I told you that in an atom or in an orbital, you can say no 2 electrons can have these same all 4 quantum numbers. That means in an orbital, or you can say in an atom, 2 electrons are never going to have the same set of all 4 quantum numbers. Max of 3 can be same, maximum of 3 quantum numbers can be same, but definitely the fourth, the spinning one, will be obviously different. That means one electron will be spinning in a clockwise, another in an anti-clockwise direction. So this led to the conclusion that means an orbital can accommodate maximum of only 2 electrons, and that must be of opposite spin. As I told you that they can have 3 set of quantum numbers same, n, l, m can be same, but definitely s is going to be different. That is why they must be of opposite spin. So what does Pauli's exclusive principle? Again, if you get a question like state Pauli's exclusive principle and also explain it, so write the first thing that no 2 electrons in an atom are going to have all 4 same set of 4 quantum numbers, right. And this led to the conclusion actually that an orbital can accommodate max of 2 electrons, and that must be of opposite spin. So how you are going to like if we are going to fill an orbital, so just look at the board how we are going to fill it. Suppose I write 3s2, that means in 3s I have 2 electrons. So how I have to put, I am just making a different you can say pattern, just tell me that which is the correct one. One is this, other is this, and other is this. So you know that like out of these 3, this is incorrect, this is incorrect, only this is correct, because as I told you that maximum of 3 quantum numbers can be same, but the fourth is definitely going to be different. But in these 2 cases what you saw that all the 4 quantum numbers are same, even the spin is same, right. So it is not possible, because in an atom all quantum numbers cannot be same for any 2 electrons. So if you will fill the orbitals, you need to fill in this way. That means one with the clockwise spin, another with the anti-clockwise spin. So this is what is the second rule which we have to follow after just writing the Bohr principle, and how we are filling the orbitals we need to use the Pauli's exclusive principle there. Third rule is Horn's rule of maximum multiplicity. Horn's rule of maximum multiplicity. What does this actually states? I'll just explain you with an example, then we'll come to the definition. See, if I tell you that I have 3p4, and one more thing keep in mind, Horn's rule of maximum multiplicity is applicable only for p, d and f orbitals. Only for p, d and f orbitals, because p, d, f orbitals are actually degenerate orbitals. They have orbitals and their orbitals are of same energy. So that this rule is being followed only for the p, d, f, or only for the degenerate orbitals. Only for degenerate orbitals, that means orbitals with same energy. In s we have only one orbital, so we won't take into consideration the Horn's rule, right. But in PDF we have like in p have 3 orbitals, d have 5, p have 3 orbitals, d have 5 orbitals, f have 7 orbitals. So that means this rule has to be followed only in these cases, that is in p, d, f. So suppose I have 4 electrons in my this thing p orbital. So that means p subshell. So how many orbitals do I have in p? As I told you, we have 3 orbitals. So that means this is my orbital. These boxes are indicating my orbitals. As they are just joined with each other and they are just belonging to a same p, that means they are degenerate orbitals. They possess the same energy. Now how I am going to fill this 4 electrons? I will make 2 cases. So one thing is that I can fill this and this like this and like this, because I know that I can just fill the electrons and that must be of opposite spin and maximum of 2. So I am just using the Pauli's exclusive principle and trying to fill the orbital. So that means this is my p4 here, and in this case if I want to write p4, 1, 2, 3 and 4. You know, out of them which is correct one? This is correct one and this is not correct. The reason behind is that this is in accordance with Hund's rule, that as we know that these degenerate orbitals are the orbitals with the same energy. So that means when we will fill the electrons, we need to fill them singly first and then the pairing will take place, right? The other reason is that, the other important reason behind the filling in this way is that when we fill in this way, right, when we just fill them singly, so that means they are maximum apart from each other. That means they have minimum repulsions, right? So that means we need to have minimum repulsions actually, because we want that our ground state configuration or a ground state configuration of an atom should be a stable one, right? So that means in that case we need to minimize the repulsions, and as we know that electrons are of same charge, so they may repel each other. So this is the arrangement in which we can keep them as far as possible to minimize the repulsion. So that is why when we fill the orbitals of the degenerate orbitals, then electron pairing in an orbital won't take place. That means we won't pair up the electron until and unless each orbital gets singly filled, right? Suppose I take an example of p3 again. So this is my p orbital and one more p orbital I am making for you in order to make you clear that which is the correct one and which is the incorrect one. So if I need to fill this 3 electrons in p orbitals, that means I will be filling like this, this or this. This is the one, probably you can say, a way of filling them. And one is that I am just pairing in the first orbital and then the leftover is done in the second orbital. So in this case the repulsion is going to be more in this case, right? And this is going to be the one in which is more stable, because electrons are as far as possible. So this is what Hund's rule states, that electron pairing, that means we won't pair up until and unless each orbital gets singly filled. As I told you that in this we have already paired first, but this orbital is vacant. So that means because they possess the same energy, that means we need to fill them singly first and then we will pair them according to the number of electrons left, right? So this is what is the Hund's rule. So these 3 rules has to be followed actually when we are writing the electronic configuration. So now we are in a position to write the electronic configuration for an element. So just like while writing, you need to keep in mind 3 rules, and the most important thing what you need to keep in mind, that is the order of increasing energies, because likewise we will be filling the electrons in them.